All right, we're also going to go into a little bit of small section on quadratics and quadratic equations. And so I want you to write what our goals are for this section. And we're really going to be going over quadratic equations with 3 videos. And so these goals that I'm about to list are really for all 3 of those, the 3 next videos. And so my goals for this section are for you to understand what a quadratic is, or a quadratic equation is, and we'll do that first. For you to be able to factor quadratic equations, and then for you to be able to solve quadratic equations. And we'll get into exactly what all of these things mean, and we'll answer that first bullet first, really quickly. You probably have seen in math class a lot of different types of equations before. Specifically, and I'm sorry I'm moving this around, I need to get to the right window. Here we go. You've probably seen linear equations, you've probably seen some different types of equations. And what a quadratic equation is all that means is it's some mathematical expression where one of the terms is being squared. Where one of the terms is being squared. What do I mean by that? Well, let's take this example. What about x squared plus 5x plus 6? This is a quadratic equation because there's multiple terms. It's a mathematical expression. Well, it's not an equation yet. This would be a quadratic expression. An equation implies that there's an equal sign. But there's a squared term, and this term, x squared, is the squared term, and that's what makes it a quadratic. When the highest term of a mathematical equation is squared, that becomes a quadratic. So this is a quadratic precisely because the highest order term, the highest term is squared. There are other terms like linear equations, and a linear equation would just be like x plus 6 equals 0. Or if we just took this part, 5x plus 6 is 0. And what makes these linear equations is that the highest order term is this term x, and it's just raised to the first power. So when the highest order term is raised to the first power, that's a linear equation. A quadratic equation is when the highest order power is squared. And there's a general form for these. The general form for a quadratic equation is this. And I want you to write this down. ax squared plus bx plus c equals 0. Let's talk about what these are. Well, the x's are our terms. Okay, so those are our variables. A, b, and c, what those are coefficients. And coefficients are just fancy words for numbers that we use to multiply things. And so a, b, and c, you can just think of them as numbers. Okay, a, b, and c are just normally going to be replaced by some numbers. And so here, this expression, this quadratic equation right here, a would be 1. There's a 1 right there. It's hidden. You can't exactly see it. B, the number that we're multiplying by the x term, is 5. And c, this number that's out here by itself, is 6. Okay, so the general form is some number times some number squared, some number times x, and some number by itself. So some number by x times x squared, some number times x, and some number over here being added or subtracted by itself. That's the general form of a quadratic equation. And these coefficients being called a, b, and c will be more important when we get to the quadratic formula. And so what we will use these to do is these quadratic equations are actually extremely helpful in solving things, especially when it comes to graphing them, which you will do a lot in Algebra 2. But what they will do for us now is they actually allow us to solve values. Okay, so let's talk about factoring quadratics really quickly. let's talk about first foiling. How would we get a quadratic? Well, a quadratic might come from the multiplication of two linear terms like this. What if I multiply x plus 2 times x plus 3? What do I get? Well, we have to, if you remember, FOIL. And FOIL stands for first, outside, inside, last. And here's what that means. You're going to be multiplying two things to each other each step along this process, FOIL. And what you're going to be multiplying for F are the first terms in each expression. Well, what's the first term in each expression? The first term in each expression is x and x. So first I'm going to multiply x times x. X times x is x squared. Now I'm going to multiply the outside terms. Well, what are the outside terms? X and 3 are the outside terms. So 3 and x, they're both positive, so I'm adding 3 times x is 3x. Now I'm going to multiply the inside terms by each other. That's 2 and x. These are two inside terms, so those are both positive, so I'm adding a 2x again. And then the last terms in each expression. The last terms are 2 and 3. And 3 times 2 is 6. And so I still have some work to do. You could see that 3x plus 2x can be simplified. And so this expression would become x squared plus 5x, 2x plus 3x is 5x plus 6. And look, that's what we have right here, what we started with. And so a quadratic can come from the multiplication of two linear expressions. And how do we multiply two linear expressions together? Well, we will FOIL them. We'll use foiling to do that. And so when we factor a quadratic, that is the opposite of foiling. We are undoing this process, right? So if we FOILed and we went in this direction, factoring is going in the opposite direction. Factoring is starting here and getting back to this point. Well, why do we factor? That's a great question. Why do we factor? Why is factoring important? If we just did this, if we just went from here and multiplied this to get here, why would we want to undo it? Well, the answer is because it's really easy to help us solve. Here's what I mean. What if I gave you this expression, x squared plus 5x plus 6 equals 0, and I said, without you doing anything, I want you to figure out what I could plug in for x here and here to make this expression equal to 0. That's what I'm saying with this quadratic. When I say x squared plus 5x plus 6 equals 0, another way to translate that is to say, what could I plug in for x to make this expression 0? If this said 1 over here or 2 instead of 0, we could read this as, let's say it said 1. What could I plug in for x on this side of the equation to make this expression equal 1? And so what this is asking us to do is solve this for x to get some number x so that when I plug that number in, it makes this expression 0. And so if I ask you just to do that without any strategy or without learning factoring, the only way really to do it would be just to guess and check, to say, okay, well, what if I start at 0 and I plug 0 into this equation? Well, I would have 0 squared plus 5 times 0, because I'm plugging 0 in for x, plus 6. And then hopefully that equals 0. Let's see, 0 squared is 0, plus 5 times 0. 5 times 0 is 0. So 0 plus 0 is 0, plus 6. Does that equal 0? No. So then we'd have to try again. We'd go, okay, let's try 1. 1 squared plus 5 times 1 plus 6. Does that equal 0? And you can see that the answer is no. 1 squared is 1 plus 5 times 1. 5 times 1 is 5, so 1 plus 5 is 6, plus 6 is 12. And we just have to keep guessing until we got it right. And so we don't have to do that. And why we don't have to do that is because you can learn how to factor. And so factoring is, like I said, is the backwards process. So we actually know where we're going to end up. Where we're going to end up is with x plus 2 times x plus 3. But how do we get there? Well, here's how factoring works. When you factor, you're going to take a quadratic equation and you're going to turn it into the multiplication of two linear expressions. So you won't always know what goes in these parentheses, but you will know that there's going to be some linear expression here, x plus something, and some linear expression here, x plus something else, and that it's still going to equal 0. Obviously, we know what the answer is, but let's talk about how do we get there. Well, how we get here is we're going to undo this process. How do we undo this process? Well, we are going to work with the factors of 6. Work with the factors of 6 to get two numbers that multiply to 6 but add to 5. I'm going to say that again. We want to find all of the factors of 6 that will multiply to 6 but will add to positive 5x. What do I mean? Let's pick two factors of 6. Two factors of 6 are 6 and 1. When I multiply them, that is 6, so that works because they multiply to 6. When I add them, though, 6 plus 1 is 7, so that won't work. So what other factors of 6 could we use? Well, you're probably already screaming at your computer screen, and you're saying, well, it's 3 and 2. Will that work? Let's see. Well, is 3 times 2 6? Yes, so that works here. And is 3 plus 2 5? Yes, it is. And so those are our factors that we're going to choose to put in here. And so when I'm undoing this, like I said, I'm going to be working with the factors of 6 to add to 5. And so we know this first multiplication is just going to be x times x. So that's always going to be x right there. And then I need to figure out what these numbers right here are going to be. And like we said, that's what we just figured out. Two numbers that multiply to 6, 3 and 2, but add to 5. In order to make positive 5, I'm going to be adding the 3 and the 2. And that equals 0. Why does that make our life simpler? Well, it makes our life simpler because now I can break each of these expressions apart, set them equal to 0 on their own, and then solve them to figure out what x should be. What do I mean? Well, I'm going to take this linear expression right here, and I'm going to set it equal to 0 by itself. X plus 3 equals 0. Now I need to solve this for x, and it's easy to see that I'm going to be subtracting 3 from each side, and I'm going to get x is negative 3. And I'm not going to work this out, but I think you could see very easily that if I set x plus 2 equal to 0 and solved it, then I would get x equals negative 2. And so I have two answers here for what x could be that would cause this equation over here to be 0, and that is what we actually use to solve quadratics. When you say solving quadratics, that means you're getting two answers right here for x that you could plug in either of these answers and it will make this expression 0. And these solutions have names. They're called solutions. These values that will make this quadratic equal to 0 are called solutions. They're called roots, and they're called zeros. Okay, and so this is just this should all be reviewed to you. So you're probably able to fly through this pretty quickly. But if not, you can watch this again. But this is how you factor quadratics, and I hope that you see why factoring quadratics is a useful skill, because it allows us to solve for these values, these solutions, these roots, and these zeros.